All right, guys, welcome back. I know that first page was kind of long. Tried talking about it the whole time. So here's page 48, and we have some more notes, kind of just reiterating what we learned already about how to write our solutions, either as coordinates, as equations, x equals some number, or x2 equals some other number, or in set notation. So basically, your notes down here now are to go ahead and find the roots. For these first three questions over here, they want you to give them in coordinate point form, so in xy form. So when you do menu 331 OK on your Inspire, your points should look like this. So number one, if you do it correctly, you get -5, -1 on your calculator. Go ahead and write those as coordinates, which means -5, -0, -1, 0, because that's why these are referred to as zeros. The next few questions, I have some notations there because there's some special things that happen. So for number 4, if you go ahead and graph that one, and you can either do it along with me or in advance, you're going to notice something special. It's x squared, so that means our a is 1, minus 6x, or our b is -6, and our c is 72. 1, -6, 72. If I use my calculator and do the menu 331 OK, so it was 1, -6, 72. OK, enter, and I get that blank box again, which means no solution. So make sure that if you type it in correctly, you get that answer. For number 5, you have to remember, for number 5 and number 6, actually, these two, make sure you put them in standard form. They have to equal 0. That means you have to move this 54, and you have to move the 7x squared to the other side of the equation before you can use them in your calculator. These will also give you decimal answers, so go ahead and round the decimals, let's say to the nearest hundredth place, to two decimal places. And write them, in this case, write them as equations. So the first x will equal some decimal number, and then x2 will equal some other decimal number. Notice that these 1s and 2s I have here over the x's are below the x and not above like exponents. So go ahead and do that with your classmates and verify that you guys get the right answers. For numbers 7, 8, and 9. So for number 7, it says find the solution set. So they want it in the brackets. So if we do x squared plus 10x plus 25, menu 331 OK. So I have a single 1x squared, which I'm putting in my calculator. It's kind of bright. Let me turn it down a little bit. See if it focuses. That's about as good as it's going to get. I have a 1 there. Down arrow, I put a 10 for the 10x. And I down arrow again for the 25. Press OK. Enter. I get -5, -5. That means I'm basically getting a graph that only touches the x-axis at -5 at one spot. So my solution set would just be -5 because it only touches at one spot. That's a very special kind of graph, but it does happen. You can have no solution, which is no answer, one answer, or the common 2 answers like we're used to. For number 8 and 9, you go ahead and just use, make sure they're in standard form, and you can go ahead and use menu 331 to go ahead and give your answers. Nothing special about number 8 or 9 that I can foresee. For number 10, here we have 2 word problems, the final 2 word problems. Our number 10 word problem says, the height of a diver standing directly above the pool during a dive can be modeled by h equals -16t squared plus 8t plus 48, where h equals the height in feet and t is the time in seconds. Find the time it takes the diver to reach the water. So if I kind of do a picture, we have a diver, I guess, up here, you know, standing above the water, and they're going to dive down. Notice we have a parabola. So we want to know how much time it takes before they hit the water, from the time they began till the time it ends. So that's what this whole function is for. Let's go ahead and clear out our calculator. By the way, if you're in Scratchpad and you have a lot of work you want to clear out, if you just press dock, the dock button, and then letter B right afterwards, press enter, it'll clear everything out for you. Or you don't press enter, just dock B and it'll clear everything out. So menu 331 OK. Our first coefficient, I just rewrote the equation, it's the same thing, is -16 for the -16t squared. +8 is my next number, and then +48 is my final one. Press OK, and then let me kind of zoom in here and kind of dim it a bit so we can see what we get for an answer. Now this is something special here. Since this is a real world problem, we have to consider the kind of answers we get. We're measuring time. A diver jumped off a diving board, and it tells us that the diver has hit the water at 2 different times, a negative time and a positive time. Well, we don't have negative time. We can't go back in time. So whenever you're talking about time answers, the negative one is not really going to help us. So the positive 2 tells us how long it took the diver to reach the water. And that would be 2 seconds after the time. So we would say time equals 2 seconds. That's how long it took the diver to reach the water. Go ahead and box in that answer for your teacher. All right, let me back up a little bit because we're a bit close. I can almost see like the molecules of the paper. There we go. All right, and number 11, a similar problem. The height of a rocket launched upward from a cliff is modeled by the function h of x equals negative 16x squared plus 160. So very similar to the last one. We have a cliff, and say, here's a mountain, here's the cliff, whatever. We have a rocket right here that's going to be shot up and hit the ground at some point in the distance. We are looking for, once again, how much time it takes from the time it's shot. We'll call this, I'll move my axis over, we'll call this 0. How much time did it take before it finally hit the ground after it was shot? Well, let's go ahead and use menu 331 to figure out how long it would take us. It's going to be a very similar problem. Menu 331, okay. I have a negative 16x squared. I have no x's, so I put 0. And then I finally have 160, which is how high off the ground the cliff is. Okay, enter. And I get 2 answers again. Let me go ahead and zoom in and dim this a bit so we can see it and hopefully make some logical sense out of our answer. We have 2 answers. We know the rocket can hit the ground twice. And we have a negative time answer and a positive time answer. If you have your calculator, the first answer is negative 3.16, and then we have the positive version of that. Obviously, we don't have negative time, so that negative answer is irrelevant. So it takes about 3.16 seconds for this rocket to hit the ground. So we'll say t with the approximation wave, not the equal, 3.16 seconds. So I know I didn't give you the solutions to the examples above, but if you use menu 331 okay and consult with your classmates or your teacher, you can easily get these. So I really don't need to reveal them to you at this point. So good luck with this assignment, and feel free to ask your teacher or go to tutoring if you need any further help. Good luck.